Well, greetings to everybody on telemarktalk.com. Wow, what a contentious debate we've had on spring cables versus flexors. This simple question sparked a huge discussion and scientific debate on skiing mechanics, and I don't want to add fuel to this fire. Science is great and we're all bound by the laws of physics, but I'd like to think that there's a bit of magic involved as well. The real magic to all of this is that two different skiers with two very different systems can have an amazing amount of fun simply by manipulating two slats through a forest filled with white wonder, all the time using the forces of gravity and the power of a Cliff Bar to create a smile that seems to last a lifetime. Last year I posted a short video review with a simple test in an attempt to show the differences in the flex resistance between the standard flexor and the hard flexor for the Rottefella Xplore binding. It was by no means a scientific measure. After reading all the discussion regarding the mechanics of the spring cable versus the rubber flexor systems, I thought it might be useful to demonstrate that the flexor does transfer forces from the boot to the tip of the ski. This is not a revelation by any means. The duckbill of the leather boot works in the same fashion. The more resistive the duckbill boot is to forward flex, the easier it is to pressure the tip of the skis. In essence, they all work in the same fashion, providing a resistive force to the forward flex of the boot. It doesn't matter if it's a sole of the boot, a heel cable, a front flexor, or the combination of all of them. They're all basically doing the same thing when it comes to putting pressure on the tip of the ski. Now that doesn't mean that they all ski the same, or that they're all equal in how much force they transfer. One thing that I want to say, it's an awful lot like trying to define the mechanics of how a person walks. You know, you can really get down to the nitty-gritty and look at all the different aspects of it, but it's really a complex system, you know, between all the muscles and the bones and all the forces and dynamics that are going on. You know, if you tried to sit down and explain it to somebody through science and physics, it could become very, very complicated. The truth of the matter is that we all do it, and it seems quite simple and it seems quite natural. And one of the important things to know is not everybody walks the same. All you have to do is watch two different people walking down the street. Everybody has their own characteristic gait. We all have basically the same build, but we all do it just a little bit differently. And I think that kind of relates to skiing as well, especially when it comes to Telemark. Everybody sort of has their own technique. We have different skis, we have different bindings, we have different boots, we have different snow conditions, and you throw all those things together, and I think it's pretty hard to put everything into a nutshell. I'm not going to try to explain the physics of skiing. I'm going to leave that to other people. I think that's just a can of worms. And what I have here is I actually have two scales. There's one food scale at the tail, and I have one food scale at the tip. Now I've got the tip of the ski constrained by a wall here because as I move this boot forward, I got to be able to measure the downward pressure on the tip, and I got to have some way to constrain that. And what I don't want to do is I don't want to apply any downward pressure on the boot itself, because I think that takes away from trying to analyze whether or not the flexor applies any downward force or whether any downward force is applied to the ski through the flexor itself. So the way that I'm going to do that is I'm just going to essentially pull the boot forward, and I'm only going to apply horizontal pressure here. This is not going to be a scientific test by any means. What I'm going to need is I'm going to need a beautiful assistant for this process. We have the scales balanced out to 0. The ski is completely freestanding. This is a set of Traverse 78s. And what I'm going to have Julie do here is she's going to apply horizontal force. She's just going to pull the boot horizontally, and we're going to see how the pressures change. And I'm not going to measure her force. She's going to keep pulling it until we get somewhere around 1,000 grams on the tip. So go ahead, Julie, just pull the boot forward. Once you get around 1,000 grams on the front, let me know. The scale on the back of the ski is showing less downward force, minus 300 grams, and the scale on the front of the ski is showing an additional downward force of 1,000 grams. Now the weight is shifted a little bit because the boot has moved forward, but most of the change is due to the interaction between the boot and the flexor. Now what we've done is we've actually removed the flexor at all, so the boot's in a kind of a free pivot mode. I want to keep the weight the same, so I'm going to set the flexor here. It's not attached to the ski. And she's going to put horizontal so the position is about the same. And on the back of the ski we're showing about 55 or 56. And about 64, 70 on the front here. Not a whole lot of change. A little bit of weight distribution, but certainly no downward force. So what I want to do now for an interesting comparative test, I've got the standard flexor in here, and I'm going to have Julie pull the horizontal force until she sees 1,000 grams on the front. Tell me when you get 1,000 grams, approximately.
There.
Okay, that gives about, just for comparative purposes, about the heel's about 8 inches above the ski to get 1,000 grams of tip pressure. Now what we're going to do is we're going to change out the standard flexor and put the hard flexor in. We're going to do the same test again. She's going to pull horizontally, and we're going to see until she gets 1,000 grams. And we're going to see how high this is.
There.
Okay, we have about 4 inches. Now I know that many of you would like me to do a comparison test with a hard wire and a cable system to see how it compares with the new Xplore system. Well, I won't, and I'll tell you why. There are literally dozens of different combinations of boots and springs and hard wires, and there's no way a bench test like this can in any way give any real indication which system is better. I can tell you that each system feels very different in how they ski, and I think the preference lies in the skier themselves. The main purpose of this simple non-scientific demonstration is to simply show that the flexor does help in adding pressure to the tip of the ski. For me, I'm happy with the skiing performance of soft boots without a cable system. It was true when my favorite system was soft leathers and 75 millimeters, and it still remains true today. Now that doesn't mean that a flexor system like the NBC or Xplore is better or worse than a 75 millimeter system with a cable. And it certainly doesn't mean you should give up your cable system and switch to the Xplore. On my downhill focused plastic boot system, I'm skiing a hardwire Switchback X2, and I love the way it skis. I think there is a time and a place where an active system works best, and then there are other times when a flexor-based system is better. It sure is a great time to be an off-trail freeheel skier. So many great choices and options. The main goal is to enjoy this sport and don't become too tribal in regards to the equipment. Advice is great, and I've certainly handed out plenty, but I fully understand that what works for me may not work for others. At any rate, until next time, be safe, be kind, and be sure to have fun.